So this is uh, this is a summary for the chapter Interior of Earth and Earth Processes. The summary mind map is basically the same thing. So the first is the source of information about the Earth crust, about how Earth is made. The direct sources are like volcanoes, and like the crust of Earth. Surface mining area, drill project, volcanic eruption, molten material are the direct source. Indirect source are like uh, properties of matter estimates, like temperature increases with depth, pressure increases with depth, and density also increases with depth. Okay, and second is a meteor, like material is similar to the structure of Earth. Third indirect source is gravity. Gravity, like also there are for gravity there are different gravities for different areas, like it's called gravity anomaly, and another is gravity is greater at the poles and less at the equators. And then like it is the fourth indirect source is magnetic field survey, distribution of magnetic materials, like different magnetic materials are like it's all around the earth, and their distribution is also a distribution of those materials around the earth, like we can, it's also one of the source. Next is the seismic activity. This is the most important indirect source. Like it tells about which part of the earth is like uh, uh, earth has some layers that are constantly engaging with each other. Like due to friction, they are holding up due to friction, but when the pressure and it gets when the pressure builds up and the friction, like it doesn't get much friction, then like this earthquakes happen and all. Now these all comes under source of information about the earth. Now the structure of earth. The uppermost is the crust. The crust is the outermost part. It is brittle in nature. Oceanic crust. Okay, oceanic crust is like thinner part, and the more thicker part is continental crust. That is in which we live in, like Asia, Australia, and the thickest it is thickest at the mountain because it's mountain area. That's why 70. The most the Himalayas is at 70 kilometers thick. Now the second structure is the mantle. It extends from most discontinuity to this most discontinuity to 290 kilometers. Like the second layer, just below the crust is mantle. The whole layer is like the whole mantle is how many? 200 2,900 kilometers thick. The most upper part is called ethnosphere. The upper mantle, it is a weak zone. It's called ethnos, means weak. It extends up to 400 kilometers. And it is the main source of lava. Lava like magma, when it comes into surface, it's called lava. But it is the main source of lava. And the second layer, like just below it is the solid state. So the question which was there in the book, in the multiple choice questions, and this question was there. Lithosphere, how is what is lithosphere made of? It is made of the crust and uppermost part of the mantle. This part and this part is made of lithosphere. Together, these are called lithosphere. And yes, and the next is it is crust and uppermost part. It is 10 to 200 kilometers thick, and the last is the core, that is at the center. So the core mantle boundaries at 200 and to every time 2,900 kilometers. The outer core liquids and the outer core is in liquid state. The inner core is in solid state. It is heavy material made of nickel and iron. The core is made up of nickel and iron. It is also refers to as knife wave. Now, going to the earthquakes. Earthquakes. Earthquakes happens to basic most easy its definition is shaking of what is called earthquakes. Now, it is the point where the energy is released due to earthquake is called the focus or hypocenter, the point where energy is released. The next is the epicenter, the nearest point on the surface of Earth, where focus is directly like the surface which is directly above the focus, directly above where the energy is released is called epicenter. The next is seismograph. It is an instrument to record waves. Next is type of waves. We know like there are two types of waves. First is body wave and surface wave. The body wave travel through the earth body, surface wave travel along the surface. It's the most damaging one. And now the body wave is further divided into two parts. The first is primary waves, which is not much as destructive, but it comes at the first. Is the first wave that comes across, and after some time interval, the second wave comes. So it's the faster right first, similar to sound wave, travel through gases, liquid and solid. Okay, and vibrates parallel, like it stretches and squeezes, and it travels parallelly. Okay, the next one is S wave. It arrives with a time lag. There is a time interval between S wave and P wave and S wave. It travels only through solid materials, it is crucial for exterior study. The next one is it vibrates perpendicular to crust and crest, to trough and crest. Okay. Next one is in the earthquakes is the shadows. It is the areas where the waves are not reported. The zone between 105 and 135 is it is for the same for P and S waves. As shadow zones are much larger, an entire zone is beyond 105. P zones band across Earth between 105 to and 145 degree. Next is types of earthquake. The first and most common is the tectonic earthquake, when the tectonic plates when they collide, sliding along the fault plane. It's called tectonic earthquake. The second one is volcanic, due to volcanic eruption confined to active volcano areas, like where the volcano are there. Mainly this kind of earthquakes occurs. The third type is collapse. The roof of underground mines collapse, where due to explosion and all. Explosion when the explosion happens, it collapses and an earthquake happens. The fourth one is explosion due to nuclear and chemical devices. The last one is reservoir induced large reservoir. Large reservoir is an area where some liquid is not liquid. I guess it's something I'm not getting. Okay, whatever it is. Let's get okay. So I'm not going to see what is liquid in large context. So the reservoir, the source state expected that earthquake that occurs in area of large reservoir refers to the reservoir in its context. It's clear one of the time it's the same thing what I said. Okay, the next one, how we measure this earthquakes. Uh, there are two types of scale in which we can measure the magnitude. Magnitude, like how much energy is released, how much is released. So it is related to Richter scale from 0 to 10. And next is intensity scale, how much damage it caused. Like on a scale is called miracle scale from 1 to 12, visible damage caused. Okay. Next is immediate hazard effect. The first is the ground shaking. The second is differential ground settlement. Third is land and mudslide. Fourth is solid liquefaction. Third is ground lurching. And fifth is ground lurching. Sixth is avalanches. Seventh is structural collapse. And lastly is tsunami only if the epicenter is below oceanic water. Okay, it's all done. The last is volcano and volcanic landforms. So let's go to the definition. Volcano definition: place where gaseous molten rock, lava escapes, magma, if material in the upper mantle, lava, magma moving toward the crust or reaching the surface is called lava. Erupted materials such as lava flow, pyroclastic debris, like pyro means fire, like yeah, debris, bombs, ash and gases. Gases, like sulfur is argon, a little amount of argon and hydrogen maybe. I have marked it. Shield volcano. Okay, now the major types of volcano. First one is shield volcano. It is largest except basalt flow. Shield volcano example is Hawaiian volcanoes made of fluid basalt lava. Low explosivity unless water enters the vent. Like the chances of getting explosion from shield volcano is very less. So the next one is composite volcanoes. It is cooler, more viscous lava, which it has thickness, much more thick lava. Explosive eruption, accumulation of lava, pyroclastic material, ashes. Now the next one is caldera, most explosive type. Most explosive collapse on themselves, collapse, depressions. Fourth one is floor basalt provinces, outposts highly fluid lava, flows long distance. It's highly fluid lava, and that means it's less viscous and thinner, but it's more liquidy, like fluid lava. Yeah, since it is less viscous and more fluid, like that's why it's like travels like a river or covers a lot of distance. And it is also our example in our India itself as Deccan traps. Deccan traps are made from basalt floored basalt provinces. Lastly, the last is mid-ocean rich volcanoes occurs in oceanic area, that is 70,000 kilometer of ridge system. Like there is a system of like cracks on in the ocean floor that spreads across the earth, and it is about 70,000 kilometers. Central portion experience frequent eruption. We don't know, like it's much more deeper in the ocean. That's why we don't know how much frequently the eruption occurs. But seismography, take it. Right. Okay, the last one is the volcano. Is volcano landforms, intrusive forms. The first one is, the ingenious rock cooled within the crust. Uh, Batholiths, largest dome cooling at deeper depth. Gran- granitic body, granitic body, cooled magma chambers. Laccoliths, large domes shape, large dome shaped intrusive bodies, level base, pipe-like conduct below. Example. So we have two examples from India itself, like Laccoliths is from forms the Laccoliths. It is present in Karnataka Plateau granite domes, like domes in the Karnataka Plateau. The granite domes in Karnataka Plateau are due to Laccoliths. Second last is Lapoliths, and Paco. PHs here Pacoliths and shells. So Lapoliths, saucer-shaped, concave to sky, like this kind of structures, like this. Pacoliths, wavy masses on the base of syn- synclines, base of synclines, top of anticlines. And third is shells and sheet. Sheet is like a very thin sheet deposit. It is near the horizontal bodies. Horizontal, like in the crust. Uh, Second last is sheet, the thinner deposit, and the much thicker deposit is horizontal deposit is shell, cell. And dike is dike, the lava solidified but perpendicular to the ground, wall-like structure, feeder to eruption, that is Deccan traps. Okay, one more time we have Deccan traps to dikes. And the last one is common in Western Maharashtra. I'm starting reading. I'm starting from chapter 3 of geography, uh, class 11th. This is for the reading session. Chapter 3 starts as it is the earth. So, what do you imagine about the nature of the earth? Do you imagine it to be a solid ball like cricket ball, or like a hollow ball with a thick cover of rock, that is lithosphere? Have you ever seen photographs or image of a volcanic eruption on television screen? Can we recollect the emergence of hot molten lava, dust, smoke, fire, and magma flowing out of the volcanic crater? The interior of the Earth can be understood only by indirect evidences, as neither any has nor any one can reach the interior of the Earth. The configuration of the Earth, the configuration of the surface of the Earth is largely a product of processes operating in the interior of the Earth. Exo, exogenic as well as endothermic processes are constantly shaping the landscape. Exo means that is uh, processes that comes from outside, and endo is like from inside. Exoskeleton of a proper understanding of the physiographic character of a region. Physiographic character of a region remains incomplete if the effect of endogenic processes are ignored. Physical geographic character like the mountains and all are remain incomplete if the effect of endogenic processes are ignored. Endogenic like that comes from inside. Human life is largely influenced by the physiography of the region. Therefore, it is necessary that one get acquainted with the forces that influence the landscape development. To understand why the Earth shakes and how a tsunami is generated, it is necessary that we know the details of the interior of the Earth. In the previous chapter, we have noted the Earth-forming materials has been distributed in the form of layers from the crust to the core. It is interesting to know how the scientists have gathered the information about this layer and these characteristics of this and what are the characteristics of these layers. This is exactly what this chapter deals with. The previous chapter is telling about the no, this is about this is the previous chapter, chapter 2. Yeah, it tells about how the crust is made. How the crust is made. I have written formation of abundantly. Yeah, it is through the process of differentiation the earth is formed. The earth forming material got separated into different layers and starting from the surface to the center part. We have layers like crust, mantle, and outer core and inner core. From the crust to the core, the density of the matter increases. Like as we go deeper, the density of the matter increases. Basically, that is what is they are saying. Also, there is one more thing. The smaller rounder object closer development to what is called planet is Indian Earth larger with collision of planet. The smaller rounded object, by the process of cohesion, develops into what is called planetesimal. It's accumulation of particles. Uh, small particles like due to gravity, everything has a small gravitational pull. That's why they get accumulated, and that process is called planetism. They're basically saying how the planets was made for chapter 2, like we are doing chapter 3 right now. So let's not get open. So the source of the information. The Earth radius is 6,328 kilometers. No one can reach the center of the Earth and make complete observation or collect sample of the material. Under such conditions, you may wonder how the scientist tells us about the Earth interior and the types of material that exist in such depth. Most of our knowledge about the interior of the Earth is largely based on estimate and inference. Yet a part of the information is obtained through a direct observation and analysis of materials. Direct source. The most direct, easily available solid earth material is surface rock, or the rock we get from mining areas. Gold mines in South Africa are as deep as 3 kilometers, uh, vertically downward. Going beyond this depth is not possible as it is very hot at this depth. Besides mining, scientists have also taken up a number of projects to penetrate deeper depth to explore the condition of the crust portion of the crustal portion. Scientists world over scientists world over are working through major projects such as yeah, this is something interesting. Setting an integrated ocean drilling project. The deepest. The deepest drill is at Kola, in the Arctic Ocean, so far as it reached a depth of 12 kilometers long. This and many drill project have this and many drill project provided large volume of the information through the analysis of material collected at different depths. Vol- Volcanic eruption form another source of obtaining that information. As when the molten lava magma is thrown into the surface of the earth during volcanic eruption, it becomes available for laboratory analysis. However, it is difficult to ascertain the depth of the source of magma. Obviously, indirect source like this. These were the direct source. Like indirect source, like we have to assume analysis of the property of material. Not assume. To analysis of the properties of matter indirectly provide information about the interior. We know through mining. We know through mining activities that temperature and pressure increases with. I mean that we know through mining activities that temperature and pressure increases with increasing distance from the surface toward the exterior of the earth. Like as we go deeper in the earth, the temperature increases. Moreover, it is also known that the density of the material also increases with depth. And what we learned from last chapter, so the density of material also increases with depth of earth. It is possible to find. It is possible to find. Is it possible to find the rate of change of these characteristics? Knowing the total thickness of the Earth, scientists have estimated the value of temperature and pressure and the density of material at different depth, like layers of Earth crust. Yeah. The detail of these characteristics refers to each layer of the detail of these characteristics with reference to each layer of the interior of this are discussed later in chapter. Okay. Another source information the meteor that all time reaches Earth. However, it may be noted that the material that becomes available for analysis from meteor is not from interior of Earth. The material and the structure observed in the meteor are similar to that of Earth. They are similar, but they are not exactly the same. They are solid bodies developed of materials same or similar to our planet. Hence, this becomes yet another source of information that the interior of the Earth. The other indirect sources include gravitation, magnetic field, and seismic seismic activities. The gravitational force is not the same at different latitudes or on the surface. It is greater near the poles. It is greater near the poles and less at the equator, like where we are living right now. Almost. This is this is because the distance from the center at the this is because the distance from the center at the equator are being greater than that of the poles. Like if we take from here India, like it will take a lot of time to get to the center. If we hypothetically this is because center equator being greater than our both. The gravity value also differ according to the mass of material. The uneven distribution of mass of materials, the uneven influence this within the Earth influences this value. The reading of gravity at different places is influenced by many other factors. These readings differ from the expected value, such a difference is called gravity anomaly. Self-explanatory. Gravity anomaly gives us information about the distribution of mass of the material in the crust of Earth. Magnetic survey also provide information about the distribution of magnetic material in the crustal portion. Magnetic survey also provides about the distribution of magnetic materials in the crustal portion. Magnetic survey, okay. Also, and thus thus provide information about the distribution of material in this part. Seismic seismic activity is one of the most important more important information about the interior of the Earth. Hence, we shall discuss it in some details. Earthquake. The study of seismic the study of seismic wave provides a complete picture. Study of seismic wave provide a complete picture of the layered interior. An earthquake, in simple word, is shaking of Earth. It is natural event. It is caused due to release of energy, which generates waves that travels in all directions. Yeah. So why does Earth shake? The release of energy occurs along the fault. The Earth is surrounded with a different fault line. Like yeah, the release of energy occurs along a fault. A fault is a sharp peak in the crust rock. The rock along a fault tends to move in opposite direction. The rocks along the fault tends to move in opposite direction. Mm, mm, As the overlying rocks strata presses them, the friction locks them together. However, their tendency to move apart at some point of time overcomes the friction. And as a result, the blocks get deformed and eventually they slide past one another. This causes a release of energy, and the energy travels in all directions. The point where the energy is released, the point where the energy is released is called the focus of an earthquake. Alternatively, it is also called hypocenter. The energy will traveling in all directions reach the surface. The point on the surface nearest to the focus is called epicenter. The point on the surface nearest to the focus. The focus from where the energy is released. It is first one to experience the wave. It is a point directly above the focus. Okay. All natural earthquakes take place in lithosphere. Lithosphere, that is Earth. You will learn about different layers of Earth later in this chapter. It is sufficient to note that the lithosphere refers to uh, the portion of depth of 200 kilometers from the surface of Earth, like from Earth to 200 kilometers, like from where we are standing. If we take 200 kilometer that is called lithosphere. The instrument called seismograph records the wave reaching the surface. A curve of earthquake wave record on the seismic graph is given on figure 3.1. Note that the curve shows three different distinct through curve shows distinct sections, each representing different types of wave pattern. The earthquake basically are of two types. Body wave earthquakes are basically of two types. Body wave and surface wave. Body waves are generated due to the release of energy at the focus dot and moves in all the direction throughout the body of the earth. Hence the name body wave. The body wave interacts with the surface rock and generate new sets of wave called surface wave. Like yeah, it is a surface wave. Okay. Surface wave. These waves move along the surface. The velocity of the wave changes as they travel through material with different densities. The denser the material, the higher is the velocity. Their direction also changes as they refract when coming across material with different densities. Okay. There are two types of body waves. There are two types of. They are called P waves. P waves move fast and are the first one to arrive at the surface. These are called primary waves. These are called primary waves. The P waves. Acha. This is primary and this is also secondary. Like mm, it, the P waves are similar to sound waves. Sound waves they travel through gaseous, liquid, and solid materials. S wave arrives at the surface with some time lag. That, therefore, it is called secondary wave. S wave arrives at the center due to some time lag. That's why it is secondary wave. An important fact about S wave is that they can only travel through solid materials. This is the characteristics of important S wave. About this fact about S wave is that they can only travel through solid materials, but this E waves can travel through all matter. All matter. Like rocks. Helps help scientists to understand the structure of the interior of the Earth. The structure of the interior of the Earth. If the reflection causes wave to rebound, whereas the refraction makes wave moves in different directions. Yeah, it depends upon the angle. It's like if the wave directly goes to a solid material, it will reflect, and if it goes in certain angle, then it will move to a different direction. That's what it is saying. The variation in the direction of wave are interfered with the help of the variation in the variation in the direction of wave are interfered with the help of their recordance is now interfered. Interfered. I don't know the meaning of this word. So the third types of wave is a shadow wave, emergence of some shadow waves. Earthquake wave gets recorded in seismograph located at far off locations. However, there exist some specific areas where the wave are not reported. Such zones are called. There exist some specific areas let me make it clear. Exist some specific area where these are not reported. Such are called shadow zones. Okay. The study of different events reveals that each earthquake reveals that for each earthquake there exists an altogether different shadow waves. Okay, different earthquakes has different shadow wave where the earthquake is the earthquake like its waves does not get recorded. The study of different events reveals that for earthquake there is a altogether different shadow waves from figure 3.2 3.2 this is the 3.2 yeah there is this no direct P wave. This is the shadow wave for P waves. This is a shadow wave for P waves, and here also S wave. This is a shadow zone of S waves. So It all the crust is the core determines where the shadow wave is formed alternatively. Uh, so where are we? Hmm. Uh, it is observed that seismograph located at any distance within 145 from within 105 from epicenter recorded that recorded the arrival of both P and S wave. However, the seismograph located beyond 145 from the epicenter. 145 is the degree. Okay, 145 degrees. From degrees from the epicenter record arrivals of. So this is beyond seismograph located beyond 145 the epicenter records the arrival of P waves, but that is not of the S wave. Thus, a zone between 105 and 145 from the epicenter is identified as a shadow wave for both types of wave. The entire zone beyond 105 does not receive S wave. The shadow zone of S wave, the shadow zone of S wave is much larger. That is shown by the figure, as shown in the figure. Is bigger. S wave, shadow zone of S wave is much bigger. The shadow zone of P wave appears as a band around the Earth, between 105 and 145 away from the epicenter. The shadow zone of S wave is not only large in extent, but also but it is also a little over 40% of Earth's surface. But the shadow zone of S wave is over 40% of the Earth's surface. You can draw the shadow zone for any earthquake provided you know the location of the epicenter. Okay, types of earthquake. The most common one is tectonic. The most common one is tectonic earthquake. These are generated due to sliding of hot rock along the fault plane. Second is a special class of tectonic earthquake is something recognized as volcanic earthquake. However, these are confined to an area of active volcanoes. This is confined to the area of active volcanoes. In the areas of intense mining activities, some of the roof of underground mines collapse due to minor minor tremor. These are called collapse earthquakes. The ground shaking may occur due to explosion of chemicals or nuclear device. Such tremors are called explosion earthquakes. The earthquake that occurs in the area of large reservoir are referred to as reservoir-induced earthquakes. Yes, large reservoir like a water body. Measuring earthquakes. The earthquake events are scaled either according to the magnitude or intensity of the shock. Either according to the magnitude or the intensity of the shock. The magnitude scale is known as Richter scale. The magnitude relates to the earth the magnitude relates to energy released during the earthquake. The magnitude are expressed in the numbers from 0 to 10. From 0 to 10, the intensity scale is named after Mercalli, an Italian seismologist. The intensity scale takes into account the invisible damage caused by the event. The range the range of intensity scale is from 1 to 12. Effect of earthquakes. Earthquake is a natural hazard. For the following are the immediate hazard effect of earthquake: ground shaking, differential ground settlement, land and mudslides, solid debris liquefac- liquid liquefaction, solid liquefaction, ground lurching, avalanches, ground displacement, flood from dams, leaf failure, fire, structural collapse, falling objects, and lastly tsunami. The first six listed above bears upon the landform. The first six landform. The first six occurs on landforms. Okay, and the landform. While other may consider the effects causing immediate concern to life and properties of people in regions. Effect of tsunami would occur only if the epicenter of the tremor is below the oceanic water and the magnitude is sufficiently high. Tsunami waves are generated by the tremors and not an earthquake itself. Tsunami waves are generated by the tremors and not earthquake in itself. Though the actual quake activity lasts only for a few seconds, its effects are devastating, provided the magnitude of the quake is more than 5 on Richter scale. This is the destruction caused by the tidal waves in Marina Beach. The destruction caused by that in Thailand. Frequency of earthquake occurrence. Earthquake is a natural hazard. If a tremor of high magnitude takes place, it can cause heavy damage to the life and property of the people. However, not all parts of the globe necessarily experience a major shock. We shall be discussing the distribution of earthquake and volcano in some details in next chapters. Note that the earthquake of high magnitude, that is 8 plus, are quite rare and they occurs only once in 1 or 2 years, whereas those of tiny types occurs almost every minute. Now the structure of Earth. The crust. The crust. It is the most outer part of the Earth. It is brittle in nature. The thickness of the crust varies under the thickness of the crust varies under the oceanic and the continental areas. Oceanic crust is thin as compared to the continental compared to the continental crust. The mean thickness of the oceanic the mean thickness the mean thickness of oceanic crust is 5 kilometers, whereas that of the continental is 30 kilometers. The continental crust is thicker in areas of thicker in the areas of major mountain system. It is as much as 70 kilometer thick in Himalayan region. 70 kilometer thick in now the secondary layer, the one below the crust is mantle. The portion of the interior beyond the crust is called mantle. The portion of the exterior beyond the crust is called mantle. The mantle extends from Moho's discontinuity to a depth of 2,900 kilometers. The upper portion of the mantle is called Ethnosphere. The word ethnos means peak. That is considered to be extending up to 400 kilometers. It is the main source of magma that finds its way to the surface during volcanic eruption. The crust and the uppermost part of the mantle is called lithosphere. The crust and the uppermost layer of the mantle are called lithosphere. Its thickness ranges from 10 to 200 kilometers. That is from the surface to bottom. That is from 10 kilometers to 100 kilometers. The word mantle The lower mantle extends beyond the atmosphere. It is in solid state, like it goes deeper. It is next. Followed is the core. As I indicated earlier, the earthquake wave velocities help help in understanding the existence of the core. The core mantle boundaries is located at a depth of 290 kilometers. The outer core is in liquid state while the inner core is in solid state. The outer core is in liquid state while the inner core is in solid state. The core is made up of very heavy material, most constituted by nickel. Nickel the core is made up of constituted of iron and it is something referred to as it is sometimes referred to as knife layer NIFE. Volcano and volcanoes and volcanic landforms. You may have seen photographs or pictures of volcanoes on a number of occasions. The volcano is a place where gases, ashes, or molten rock materials such as lava escape to the ground. A volcano is called an active volcano if the material mentioned above are like released when there is an volcanic eruption. The layer below the solid crust is mantle. It has higher density than that of the crust. The mantle contains a weak zone called atmosphere. It is from this that the molten atmosphere. It is from this that the molten rock materials find their way to the surface. The material in the upper mantle portion is called magma. Material in the upper mantle is called magma. Once it starts moving toward the crust or it reaches the surface, it is referred to as lava. Like when it's inside the earth is called magma, and when it reaches the surface it is called lava. The material that reaches the ground, includes lava, pyroclastic, plastic debris, pyroclastic debris, volcanic bomb, ashes and dust, and gases such as nitrogen compound sulfur. So this is the compound that gets out of this nitrogen compound, sulfur compound, minus fluorine and hydrogen and argon. Volcanoes. Material that reaches lot of bioplastic debris, volcanic volcanoes are classified on the basis volcanoes are classified on the basis of nature of eruption and the form developed at the surface. Major types of volcanoes are as follows. The first is shield volcanoes bearing the basalt flow. The shield volcanoes are the largest. Which are the largest shield volcanoes? Are the largest volcanoes of the earth. Largest. Largest volcanoes. The largest of all volcanoes on Earth. The Hawaiian volcano. This is an example. Are the most famous. Example. These volcanoes are mostly made of basalt. These volcanoes are mostly basalt, a type of lava that is very fluid when erupted. For this reason, these volcanoes are not steep. They become explosive if some water gets into the vent. Otherwise, they are characterized by low explosivity, characterized by low explosivity. The upcoming lava moves in form of a fountain and throw out the cone at the top of the vent and develop into a cylindrical cone. Cylindrical cone. Now the second type is composite. First one is field, the second is composite volcanoes. These volcanoes are characterized by eruption of a cooler and more viscous viscous lavas than basalt. These volcanoes often result in explosive eruption. These volcanoes often explosive eruption along with lava. Large quantities of pyroclastic material ashes find their way to the ground. These material accumulate in the vicinity of the vent openings leading to formation of layers, and this makes the mountain appear as a composite volcano. Yes. Now the third one is this looks like Mount Fuji. This is it Mount Fuji. Caldera. The third type is a caldera. These are the most explosive of the Earth's volcanoes. They are unusually so explosive that when they erupt, they tend to collapse on themselves rather than building any tall structure. The collapse depression are called calderas. Their explosiveness indicate that the magma chamber supplying the lava is not only huge but also in close vicinity. Now the fourth is floor basalt provinces. These volcanoes outputs highly fluid lava that flows for long distance. Some parts of the world are covered by thousands square kilometers of thick basalt lava flows. There can be a series of flows with some flows attaining thickness of more than 50 meters. Individual flow may extend for hundreds of kilometers. The Deccan Trap from India is the most famous example of this. The Deccan Trap from India is presently covering the most of the Maharashtrian plateau are much larger border mountains. So that means the Deccan Traps are made from calderas, no, not calderas, from flood basalt provinces. It is believed that initially the trap formation covered much of larger area than the present. So it covers much larger area because it goes hundreds of kilometers. Okay, and now the last one is mid-ocean ridge volcanoes. These volcanoes occurs in oceanic areas. There is a mid-ocean ridges more system of mid-ocean ridges more than 70,000 kilometers long that stretches through all ocean basins. The central portion of this ridge experience the central portion of this the central portion of this ridge experience frequent eruption. We shall discuss now in the next chapter. Volcanic landforms, intrusive forms. The lava that is released during volcanic eruption on cooling develops into igneous rocks. So the lava is particularly an igneous rock. Ingenious Cooling may take place either on the surface or also while the lava is still on the crustal portion, depending on the location of the cooling of the lava. Ingenious rock are classified as volcanic rock, cooling at surface, and plutonic rock, cooling on crust. So ingenious classified as volcanic rock that cools on the surface and plutonic rock that cools on the crust, that is inside the cooling the crust. The lava that cools within the crust portion assume different forms. These forms are called intrusive forms. Some forms are shown in 3.5 meters. Lava creating lava mesh, composite rock, composite volcano. It has a deep kind of structure, ash cone volcano, and lava volcanic rock with radiating dikes, calderas, caldera with cider cone on the floor. Intrusive form. Next one is batholith. A large body of magmatic, a large body of magmatic material that cools in deeper depth of the crust develop in the form of large stone. They appear on the surface only after the denudation. They appears on the surface after denudational processes. Only after the denudational denudational process removing the overlying material. They covers large areas and at times assuming depth that may be several kilometers. These are gigantic bodies. Batholiths are the cooler portion of the magma chamber. Okay. This is batholith. Okay. A large magnetic material. Okay. This is magma. This is literally magma. Let's cover this. Now the second is laccoliths. These are large dome-shaped intrusive bodies with a level base and connected by pipe-like conduit from below. It resembles the surface volcanic dome of composite. Volcano. Only these are located at deeper depth. It can be regarded as the localized source of lava that finds its way to the surface. The Karnataka plateau is spotted with normal hills of granite rocks. Most of these are exfoliated or example of batholiths. Lacoliths and batholiths. Lapoliths, lapoliths, pacoliths, and cells. As and when the lava move upward, a portion of the same, as and when the lava moves upward, a portion of the same may tends to move in a horizontal direction. As the mass moves upward, a portion of the same may tends to move in the horizontal direction whenever it finds a weak plane, and it may get rested in different form. In case it develops into a saucer shape concave to the sky body is called lacunates. This is like dome-like structure where lacunates are like when they find a weaker section of this crust, it gets accumulated. That's why it forms a like dome-like structure. Oh, nice. A wavy mass of intrusive rocks at times is found at the base of syncline or at the top of anticline. A wavy mass of intrusive rock at times is found. Such wave materials have a definite content source beneath in the form of magma chambers that prevent to the ground. These are called pathologics. Let's see where it's pathologics. I think pathologics, but I can't see pathologics. Eroded lacunates. There are also lacunates. Diatreme. Excuse me. Near horizontal bodies of the intrusive igneous rock are called shales. Near horizontal bodies of the intrusive igneous rock are called shales or sheets. Sheet or sheets. Okay. These are like horizontally aligned horizontal bodies of intrusive rock are called shales. Depending on the thickness of the material, the thinner ones are called sheets, while the thicker one is called shales. Okay. The thinner one is called sheet because it's same as sheet, while the thicker horizontal deposit is called shales. Now the last one is dike. When the lava make its way through crack and fissures. Okay, when the lava makes its way through crack and fissures develop in the land, it solidifies almost perpendicular to the ground. It gets put in the same position to develop a wall-like structure. Such structure is called dikes. Such structure is called dikes. Let's see what is dike. Okay, this is the dike. These are the most commonly this is the most commonly found intrusive form in the Western Maharashtra area. Okay. Maharashtra area. These are considered the feeder of the eruption that led to development of Deccan Tract. So dikes are the most so let's go through these. Which of the following earthquakes are most destructive? Most destructive is surface waves because it has more intensity more amplitude. Which of the following is a direct source of information about the Exodus? Direct source, direct source of information. Volcanoes are a direct gravitational. process of indirect. This is indirect. Gold mines, volcanic eruption. Okay, volcanic eruption is another source of evidence. So we have an example. This month, this green volcano is not direct information. Drill manipulated gold mines, solid earth surface, most easily available earthly available surface rock, also mining is volcanic is the answer, and also some volcano. This type of volcanic eruption is called volcanic. The basalt province. Floor basalt provinces. Flood basalt provinces. Yes. Which of the following describe lithosphere? The crust of the core, the crust and upper crust and upper mantle. Yes. What is body waves? It's completed. There's one more thing I want to show.